Hi everyone, my name is Aditya.
My name is Becca, and this is Brainfuck, hereafter referred to as BF for obvious reasons. BF is an esoteric programming language, also known as an SOLang. The goal of an SOLang is to test the boundaries of programming language design as a proof of concept, as software art, or as a joke. The goal is almost never usability. BF was designed in 1993 by Urban Mueller for the Amiga operating system. His goal was to create the smallest possible compiler for a Turing-complete language. He managed to do this in 240 bytes. He uploaded it to the largest public archive of software in the world at the time, which he actually managed himself. He posed BF as a challenge, and I quote, "Who can program anything useful with it?" BF has become the most famous esoteric language and has inspired many other languages. It is often referred to as Brain F with asterisks, Brain F, and BF to avoid offense.
Okay, so we are going to look at the BF commands, and there are only 8 commands in all, and they are easy to remember and easy to implement. The greater than symbol, which increments the data pointer, and it takes your data pointer to the right of the current location. Then the smaller than symbol, which decrements the data pointer by 1 and takes it to the left of the current location. We have the plus symbol, which increments the value or the byte at the data pointer by 1 each time you use it. So if you have a large value, say 10, you will have to use it 10 times to get 10 stored in that current cell. Then we have the minus symbol, which decrements the byte at the data pointer. We have the full stop or the dot, which gives you the output of the byte or the value that the current cell holds. Then we have the comma, which accepts 1 byte of input and stores its value in the current data pointer. We have the square brackets, which can be used as the jump if statement or as for loops. We are now going to look at how to BF using the commands that we saw previously. Now, how BF works basically is using an array which is empty by default, and the data pointer is always located at the beginning, that is at the left of the array. So what we are seeing here is the greater than symbol. What it does is it takes the data pointer to the right by 1, which again holds the value 0. Now what we have done here is we have used the plus symbol like 65 times to store the value 65 in the second cell. So this is how the plus symbol works. As I said, if you want to store some big value, it's annoying. You will have to use it that many times to store that value. Or you can use loops, which we are going to see later. So we have 65 stored here in the second cell, and then I'm going to use the dot or the full stop, and what that is going to do is give me the output as the uppercase A. Why? And that is because 65 is the ASCII value for the uppercase A. Now if I used a smaller than symbol and went back to the previous cell which holds 0, I'll get the output as 0. Okay, so we saw how we can use the plus symbol 65 times to just print out the uppercase A, and that can become annoying at times. So we are going to look how we can print out A using loops, and it is pretty easy. So we know that by default the data pointer is always located at the left of the array, that is at the beginning of the array, and it stores the value 0 by default. So what we do here is that we increment the first array cell by 6, and then it holds the value 6, and then we start the loop. We come to the second cell, increment it by 10, and then come back to the previous cell and start decrementing it, and that's where we end our loop condition. So what happens at the end of the loop is that this loop, the inside of the loop, that which is pretty much the second cell which holds the value 10, is going to run 6 times, and it will end up holding the value 60 at the end and exit the loop. And when that is done, we will come back over there in the second cell and increment the value by another 5, and that is how we are going to hold the value 65 in the second cell. And then we are going to use our full stop or the dot to have the uppercase A printed out. So now we're going to look at the basic input and output operations, that is how we can take the input from the user and print it out. So what we have here is the empty array with the data pointer at the beginning of the array, and we are going to use the small code, which is basically nothing but the commas and the greater than symbol. And what this code does is it takes up to 3 cells and holds 3 different values into the array. So the first one, say the user inputs 1, 2, 3, so the ASCII values of 1, 2, 3 will get stored in the first 3 cells of the array, and at that point the data pointer will be in the 3rd cell. So if we want to print it out as 1, 2, 3 in that particular order, we'll have to bring back a data pointer to the beginning of the array and then use the full stops, the greater than symbol, and in the similar way that combination to print out 1, 2, 3 again. Okay, so looking at the compilers for the language, the creator of the language, Urban Mueller, his goal was to implement the smallest compiler possible. So he came up with his first implementation, which was as big as 240 bytes. He was later able to improvise on it and was able to bring it under 200 bytes. We have some that exist even under 100 bytes today. Now, the most common implementations of the compilers and interpreters are written in C, Java, and JavaScript, and also Python. The link below, the given link, will take us to one of the JavaScript compilers, which is an in-browser execution environment, and this link will take us to the download page for the Windows IDE execution environment.
The goal of BF is to amuse and challenge programmers. So even though BF is Turing complete, which means that it could theoretically compute anything computable by modern programming languages, most BF applications are designed to test what that particular programmer can actually make using BF. So a lot of these programs are mathematical algorithms, like outputting an arbitrary number of the Fibonacci sequence or factorials, although there are some higher level applications that do exist. For example, this is a BF implementation of the Mandelbrot set, which outputs fractals. And here is a BF implementation of the Towers of Hanoi, which is a pretty famous mathematical puzzle. So here is the standard Hello World program for BF. As you can see, it is pretty difficult to read and to see what's going on here. So I'm going to go ahead and take you over to the JavaScript BF interpreter that we mentioned earlier. So I just copied and pasted the entire program. There's no input for Hello World, and I'm just going to click execute. And you can see that the output is Hello World. Now this particular interpreter also has an execute trace and compile to C function. So you can see in the trace that it actually kind of goes step by step to see what values you're putting in which register, which can be really useful for debugging. So now I'm going to go line by line through this Hello World program and kind of explain what's going on here. As you learned earlier, these square brackets are used for looping. So we're going to set our cell number 0 to the value of 10, and that's basically going to be our counter. So every time that we hit this square close bracket, we're going to check to see what this value is at cell 0, and once that's 0, then we're going to exit the loop. While we're in the loop, we're going to operate on 4 different cells, adding a certain number to each. So for cell 1, we're going to be adding 7 to it, and we're going to do that 10 times, getting us to a value of 70. And we're doing the same for 2, 3, and 4 for the values of 100, 30, and 10. Once we have those initial values, we're going to go ahead and start using them. We're going to use cell number 1, increment it to 72, and that corresponds to the ASCII value for H, so we're going to print that out. Then we're going to move on to cell number 2, increment it by 1, get the value of 101, which corresponds to the ASCII value of E, print that out. So you can see that we're moving back and forth between these 4 cells, incrementing and decrementing in order to get the letters that we want. Now we're not using a cell for each letter because that would create a really long program and would use an unnecessary amount of space.
One piece of code that Becca and I put up together from our side just to demonstrate one of the implementations of BF programs, and now we're going to look at it. So this is the Windows IDE execution environment that we spoke of earlier, and I have the code there already. I copy pasted it, and I'm just gonna hit run over there, and there you go, we have hello Dr. Femiani.
P is a theoretical language designed in 1964 to describe a family of Turing machines. BF fits into that framework for describing programming language, but was not directly influenced by P. In fact, Mueller probably wasn't even aware that that language existed. He was aware of the 93 false language designed by Wouter van Ortmerson, which was an intentionally obfuscated language with a tiny compiler. It had about 1,000 bytes. Here is an example of a program written in false, which as you can see is almost harder to understand than BF, but it had a tiny compiler, and that's what inspired Mueller to create his language. The main features of BF are that it's Turing complete and it has a tiny compiler. That's pretty much it. The only other thing that it's known for is that it's difficult to read and to write, although it has had an enormous impact, inspiring many other esoteric languages. There are equivalents, whose commands directly map to BF, and derivatives, which are languages that extend BF's behavior. One example of an equivalent is the OOK programming language, which maps directly to BF, but is written in orangutan. Here are the OOK commands, which as you can see map directly to BF, but are basically just different permutations of OOK with some sort of punctuation at the end.
Enjoy getting BF'd.